Hey guys, and welcome to a video where we'll be discussing moles, molar mass, and everything in between to understand the conversion of this. So, what is a mole? Well, we can define a mole as 6.022 times 10 to the power of 23 of something. This can be anything. It can be applied to donuts or jugs of milk or watermelon, anything like that, random. It's just the saying like 1 dozen is 12 of something, like 12 eggs or 12 jugs of milk or 12 watermelon. So with that, to get started with the mole and mass conversion, we can move on to atomic mass and grams per mole. So if I'm given carbon, right, this has an atomic mass of about 12. You can use your periodic table or something. So the AMU of carbon is about 12. So this saying atomic mass can also be applied to the same element representing its molar mass in grams per mole. So if the atomic mass is 12, that means the grams per mole is also 12. So there are 12 grams of carbon in 1 mole of this. So if I also, let's say if I have nitrogen, right? Nitrogen has an atomic unit of, I think, or actually let's use hydrogen for example. Hydrogen has atomic unit of 1.008. So with that, I could say the atomic mass unit of hydrogen is about 1, or you could just say 1.008. And with that, it has also 1 gram per mole, or 1.008 grams per mole. Like this. And that applies for all elements. So the molar mass is equal to the atomic mass units of that element. So let's move into conversion. So I really want to bring out this conversion chart, that I found extremely useful to work with. So this conversion chart is extremely handy when you're doing mass and mole conversions. So as you can see, you multiply by the value indicated. So if you're given grams, right, and you want to get to moles, you have to multiply your grams by 1 mole over the molar mass in the specified grams. So I can give like some practice problems and you can try and play around with it. So we're being asked how many moles of acetic acid, which is this compound, are contained within 24.71 grams of it. So if we want to go from moles, right, and we're given the amount in grams, which is 24.71, we can already write 24.71 grams. But to get the molar mass, because we want to get to moles, we have to find the molar mass of this compound. So if we pull out CH3COOH, right? Carbon has 12 plus hydrogen has 1, so 1 times 3. And carbon another 12, oxygen has about 16, oxygen another 16, hydrogen 1. So if you add all of these together, right, you get about 24 plus 3 is 27 plus 32 is about, I think, 60. Let me just double check my calculator. Don't want to mess up. Yeah, we have 60. So this gives us 60 grams per mole. But when trying to go from to get to moles, we're given to specify just the gram value of this. So we can multiply 1 mole over just 60 grams. And this will give us the amount in moles. So if we cancel this gram, we get about 24.71 over 60. And this will give us the amount in moles. So if I put it in my calculator, we get 0.41183 repeating moles. So this is our final answer to find it. So there are this amount of moles in 24.71 grams of acetic acid. So yeah, just working around with the conversion chart is extremely helpful. So you could memorize it, but if you want to understand the logic, you just want to cancel out what you're trying to look for. So if you're trying to get the moles, you want to try to cancel out like the grams. Like you see, like if I want just moles, I want to separately just cancel out grams by itself. So let's move on to this problem. So how many moles of sodium carbonate, hold on, I just want to pull up the periodic table here. So how many moles of sodium carbonate, which is this compound, are contained in 57.3 grams of this compound? So like before, we're given 57.3 grams, and this time I can just specify the compound so you can kind of visualize it a bit more, of sodium carbonate, right? So we have sodium, which has a molar mass of about 22.9990, so I can just round it to 23. So this is given twice, so this is given plus 23, because we're given twice of this. We have carbon, which is about 12, and we have oxygen, which is O3, which is about 48, because 16 times 3 is 48. Yep. So if we add all of this together, right, we have 46 plus 12 plus 48. So we get about 106 grams per mole in sodium carbonate. So that means there's 160 grams in 1 mole for sodium carbonate. So then again, we look at our conversion chart, right? We're given grams, and if we want to get to moles, we have to multiply this 1 mole by the molar mass just using only specified grams, which is just 106 grams. So then we can cancel. So we're given 57.3 times 1 mole, or just mole, over 106, which can give us 3 divided by 106, which gives us about 0.54056 moles, and that's the final answer. So that means there's this many moles in 57.3 grams of sodium carbonate. Okay, so now we're given a different type of conversion. How many grams of NaOH? This is what we're looking for. And we're given this much. We're given 0.785 moles. So we already know our starting volt value is going to be moles, right? So let me put it in a different color. Increase the thickness maybe. 0.785 moles. And to get to grams, right, we have to multiply them by the molar mass in grams per mole to get to that. So then we have to find how many grams per mole there is in NaOH. So Na has about 23, oxygen has about 16, hydrogen has about 1. Just round it per se. So if you do 24 plus 16, that's like sorry, my mental math is a little bit nervous on right now. So we have about 40 grams per mole. So we can multiply, going from moles, right, to molar mass using both the gram over mole value. So we can multiply by just 40 grams per mole. Actually, let me put it like this. 40 grams over 1 mole. And like I said before, if you want to do it logistically, just trying to find you can just cancel what you're looking for. So you remove mole, so then you're left with 0.785 times 40 grams, and this will get you, put in my calculator, this gets you about 31.4 grams. That's your final answer. So there are 31.4 grams and 0.785 moles of NaOH. So this is actually super simple, if you can just learn how to do it. You don't have to memorize. I mean, I memorized it, but just whatever works for you. Okay, so now we're given this. This is called formula units. And one thing to note is particles. This can be noted as. There's other names for this. You can note it as formula units. Like when you're doing a problem, this can be in atoms or molecules. So if the question says if it was instead how many moles of lithium are present in a sample that contains 2.47, let's say it had molecules, it's the same thing as just particles on this conversion chart. So particles can mean formula units, atoms, molecules, and like, yeah, that stuff. So don't get like confused when you don't see it on there. So in this example, we were actually given the formula units, right? Which we can just denote as particles. And when we want to find how many moles, this is what we're looking for. So to get to that, we have to go to this way and we have to multiply 1 mole over Avogadro's number, which is 6.022 times 10 to the power of 23. So if you do it like that, right, you're given 2.47 times 10 to the power of 87. And when doing this conversion, you actually don't need the molar mass because you're going from formula units to moles. So you're given this and you want to multiply this by, or you can divide, either way works, but I'm just showing the process. 1 mole over 6.022 times 10 to the power of 23. So if you do this, it'll just be 2.47 times 10 to the power of 87 over 6.022 times 10 to the power of 23 moles. So if I put this in math way, or like any calculator, because I don't have one on me right now, I can just multiply. Hold on, it's a bit tinier. And also, just remember to put parentheses because when you're working with scientific notation, because it might mess up your problem at times. 2.47 times 10 to the power of 87. So this gives us about 4.1 times 10 to the power of 63. 1 times 10 to the power of 63. And that is your final answer in moles. Okay? So it's actually super simple, like I said many times. Okay, let's work with... Actually, I think that's done. So if you guys actually understood the problem, it's actually really easy to work with conversions in moles and molar mass. So if you guys enjoy the video, just make sure to comment down below if you want to see more content. Thank you.